Hi everybody! Today we're going to be talking about functions, and this is very related to everything we've been doing in Chapter 3. We're just going to give it some more fancy mathematical names, but it's very similar to what we've already been doing. This goes with the learning goal. I can represent functions with equations and tables. So we have two vocabulary terms in this section. We need to know what is a function, so we can talk about them, and then we're also going to talk about what is a function rule. So what is a function? A function is a relationship that assigns exactly one output value to each input value. So if you remember back to elementary school, we used to have these things called function machines, and that was actually getting you ready to learn about functions. And so you would put a number into the function machine and out would come another number. And so what this is saying is, in order for something to qualify and officially be a function, when you put in an input in, you can only get one output out. So if I put a 2 into my function, I can only get one unique value out. I can't put in a 2 and one time get a 5 and then put in a 2 and one time get a 3. That won't work. Okay, so a function rule is related to a function. A function rule is just an equation that describes a function. So these are those equations that we've been talking about, and most of the equations that we've been talking about do fit into the classification of functions. So I put one input in, I get exactly one unique input out. So here's an example. Iowa requires that you give a 5-cent deposit on drink containers when you buy things. So cans and bottles, just like we know. This is to encourage recycling. The total amount of money that you earn for returning containers depends on how many containers you return, obviously. So you get 5 cents per container. So I've written a function rule right here, and you can see that I'm using the variable c here for representing the number of containers, and I'm using the variable d here to represent the amount of money that I'm going to get back for the deposit. So if you look at this, you can see that C is going to be my input. So whatever I put in for C, the value of D is dependent on that input value. And so D is my output. So that means that whatever I put in for C, if it's unique, I have to get one value for D to come out. So if I put 5 in for C, I can't get 2 different deposit amounts. I'm only going to get 1 deposit amount. So that means that this is a function. And one thing that we do with functions sometimes is we create an input-output table, which you can see over here to the right. So for each value of C, I can figure out how much deposit I'm going to get back. So if I deposit 6 containers, if I return 6 containers, then I am going to evaluate my function. So I'm going to do 0.05 times 6. Oops. And that's going to give me my output value, how much I'm going to get back. So I would get back 0.30 or 30 cents back for depositing 6 containers. If I deposit 12 containers, if I bring 12 containers back, I'm going to figure out how much money I'll get by doing 0.05 times 12. And I know that 5 times 12 is 60, so I'm going to get 60 cents back. And if I deposit 24 containers, I'm going to do 0.05 times 24, which would give me $1.20 back. And so I can fill out this input-output table just by evaluating my function for each input value that I put in for C. And this is the same thing that we've been doing, we're just putting slightly different terms on what we're doing. Sometimes when we write a function, instead of writing it this way, we're going to write it the bottom way here. And this is just a special, it's called function notation, and it just looks a little bit different, this does not mean f times c. We read it as f of c. f of c equals 0.05c. And the c here is just telling me this is the input variable. So we just don't say what the output variable is. We're using this f of c to represent the output of our function. It's just another way of writing functions and looks a little bit different, but it means the same thing. So when I write my input variable this way, I could say I want to evaluate my function for 6 cans. I could write f of 6, and that would mean substitute 6 in for my variable c into my function. And it's just a little bit different way of writing it. So here's an example of how that might look. They ask you to use this function rule, which is just an equation. I could rewrite this function if I find this confusing. I could rewrite it as y equals negative 4x plus 12, and that means the exact same thing. So over here, where it's telling me to find f of negative 7 and f of 3, that just means substitute negative 7 in for my variable x, my input variable, and substitute 3 in for my variable x, my input variable. So I could, again, just using this equation, it's just telling me to substitute negative 7 and 3 in. So I'm going to do that and see what I get for y. So negative 4 times negative 7 plus 12 gives me a positive 28 plus 12, which equals 40. So I would say f of negative 7 equals 40. And then I would also find f of 3, so that would be negative 4 times 3 plus 12 equals 0. So then I would write that f of 3 equals 0. And so it's just a matter of substituting that number in for my input variable, which is the x in this case. I know that's the input variable because I can see it right here, and that is always the input variable right there. The answer to the free response question, if you're in Spillman's class, is spaghetti noodles. And here's your multiple choice question. So go ahead and pause the video now and answer your multiple choice question.